Statistics in Anthropology. Topic 1.4, Part B. Parametric test. A parametric test in statistics refers to a type of inferential statistical test that makes specific assumptions about the population from which the sample is drawn. These assumptions generally involve the parameters of the population distribution, such as its mean and variance. Parametric tests are widely used because they are typically more powerful and efficient when the assumptions are met. Below is a detailed explanation. Key characteristics of parametric tests. 1. Population assumptions. The data is assumed to come from a population that follows a specific distribution, most commonly the normal distribution. Parameters like the mean, mu/mu, and standard deviation, sigma/sigma, are often central to the analysis. 2. Scale of measurement. The data should be measured on an interval or ratio scale. These scales have meaningful distances between values, enabling arithmetic operations. 3. Homogeneity of variance. In cases where comparisons are made between groups, the variances of the groups are assumed to be equal, homoscedasticity. 4. Independence of observations. Observations within the sample must be independent of one another. Examples of parametric tests. 1. T-test. One sample t-test tests whether the mean of a single sample differs from a known population mean. Independent samples t-test compares the means of two independent groups. Paired samples t-test compares means of two related groups, e.g., pre-test and post-test. 2. Analysis of variance, ANOVA. Used to compare means across multiple groups to determine if at least one group mean is significantly different. 3. Regression analysis. Explores relationships between dependent and independent variables under the assumption that errors are normally distributed. 4. Pearson correlation. Measures the linear relationship between two continuous variables, assuming data are normally distributed. 5. Z-test. Used for testing the mean of a sample when the population variance is known. Advantages of parametric tests. 1. Statistical power. Parametric tests are generally more powerful than non-parametric tests when assumptions are met. This means they are more likely to detect a true effect. 2. Interpretability. Results are often easier to interpret because they are based on specific mathematical models. 3. Flexibility with complex data. These tests can handle a wide variety of scenarios, such as multiple predictors in regression analysis. Limitations of parametric tests. 1. Assumption dependence. Results may not be valid if the assumptions, e.g., normality, homogeneity of variance, are violated. 2. Sensitivity to outliers. Outliers can greatly affect the results because parametric tests rely on means and variances. 3. Not suitable for ordinal or nominal data. These tests require interval or ratio level data and are not appropriate for data measured on ordinal or nominal scales. When to use a parametric test. The sample size is sufficiently large. As per the central limit theorem, large samples tend to approximate a normal distribution even if the population distribution is not normal. The data meets the assumptions of normality, homogeneity of variance, and independence. If these conditions are not met, non-parametric tests, e.g., Mann-Whitney test, Kruskal-Wallis test, are preferred. Conclusion. Parametric tests are powerful tools for statistical inference, relying on assumptions about the population's distribution. Understanding when and how to use them is essential for accurate data analysis. However, ensuring the are met met is crucial to ensure the validity of the results. Non-parametric test. A non-parametric test in statistics is a type of inferential test that does not require strict assumptions about the population from which the data is drawn. Unlike parametric tests, non-parametric tests do not assume that the data follows a specific distribution, e.g., normal distribution, or that population parameters like the mean or variance are known. These tests are often used when the data violates the assumptions required for parametric tests or when the data is ordinal, nominal, or not normally distributed. Key characteristics of non-parametric tests. 1. Distribution-free. Non-parametric tests do not assume any specific probability distribution for the population data. 2. Scale of measurement. These tests are well suited for ordinal or nominal data, but they can also be applied to interval or ratio data if assumptions for parametric tests are violated. 3. Robustness. Non-parametric tests are more robust to outliers and deviations from normality. 4. Rank-based methods. Many non-parametric tests involve ranking data rather than using raw values. Examples of non-parametric tests. 1. Tests for differences between two groups. Mann-Whitney U-test. Compares the medians of two independent groups, non-parametric alternative to the independent samples t-test. Wilcoxon signed rank test. Compares paired data or matched samples, non-parametric alternative to the paired t-test. 2. Tests for differences among multiple groups. Kruskal-Wallis H-test. Compares medians across more than two independent groups, non-parametric alternative to one-way ANOVA. Friedman test. Compares multiple paired groups, non-parametric alternative to repeated measures ANOVA. 3. Tests for relationships between variables. Spearman's rank correlation. Measures the strength and direction of association between two ranked variables, non-parametric alternative to Pearson correlation. Kendall's tau. Another measure of correlation for ranked data, especially useful for small datasets. 4. Tests for goodness of fit or independence. Chi-square test. Tests the association between categorical variables. Kolmogorov-Smirnov test. Compares a sample distribution to a reference distribution. Advantages of non-parametric tests. 1. Fewer assumptions. No requirement for normality or homogeneity of variance. 2. Flexibility with data types. Suitable for ordinal, nominal, or non-continuous data. 3. Robustness. Less sensitive to outliers and skewed distributions. 4. Applicability to small samples. Effective with small sample sizes, where normality assumptions cannot be reliably tested. Limitations of non-parametric tests. 1. Less statistical power. Non-parametric tests are generally less powerful than parametric tests when parametric assumptions are met, meaning they may require larger sample sizes to detect a significant effect. 2. Loss of information. Since many non-parametric tests use ranks instead of raw data, some information about the data may be lost. 3. Limited for complex models. Non-parametric methods are less well developed for advanced statistical modeling compared to parametric methods. When to use non-parametric tests. Data characteristics. Data is ordinal or nominal. Data is not normally distributed, even after transformations. There are outliers or skewness that cannot be adjusted. Sample size. The sample size is small, making it difficult to validate parametric assumptions. Measurement scale. Variables are measured on a rank or categorical scale. Comparison between parametric and non-parametric tests. Aspect. Parametric tests. Non-parametric tests. Assumptions. Requires specific assumptions, e.g., normality. Fewer assumptions, distribution-free. Data type. Interval or ratio scale. Ordinal, nominal, or interval/ratio scale. Efficiency. More powerful if assumptions are met. Less powerful but robust. Outlier sensitivity. Sensitive to outliers. Robust to outliers. Conclusion. Non-parametric tests provide a flexible and robust alternative to parametric tests, particularly in situations where data do not meet the stringent assumptions of parametric methods. Although they may lack power compared to parametric tests, their versatility and ability to handle non-normal data make them indispensable tools in statistics. Understanding the nature of your data and the context of your analysis is crucial in choosing between parametric and non-parametric tests. Parametric and non-parametric test classification in one frame. Upcoming topic 1.5 Techniques of Analysis. Thank you for watching. If you found this helpful, don't forget to like, share and subscribe. Follow us on YouTube. Anthronet Academy. Stay connected. We're here to support your UGC NET exam journey to success.